Hey everyone.
Morning.
Morning.
Good morning.
Good
Welcome,
morning.
everybody.
All right, we're getting lots of attendees.
Yeah. Hello, everybody.
Good morning.
Morning. Good morning.
Where's
Hi.
everybody from? Croatia, Zurich,
Chile.
Florida.
Hey
Hi,
Florida.
Cinda.
I can see a lot of chat going by,
Jeez.
Yeah.
people
Wow.
checking in. How many people are on? Can you tell?
We're about to hit 500. We've now surpassed that. We have 2,500 people registered, so we'll see how many come.
Very good.
Yeah.
Rachel, I think I've seen about 20 countries so far.
Yeah, there's
Wonderful.
a lot. Peru, Canada.
India,
So
Germany.
you guys,
Tanya?
it was a magnitude 4.5.
Oh wow.
Wow.
Yeah.
Yeah, everyone. Bill just was in a little earthquake for.
Yeah, the place shook pretty well. And so just generally after there's one, you're going to expect a couple more aftershocks.
Make this a really exciting launch.
The Earth is excited.
Mhm.
Yeah, that's what it is. Yeah.
Yeah, this is the season for pushing vehicles to Mars. So the Earth is giving a big woohoo.
Oh,
Mhm.
can I say hi to Lucia from Toms River, New Jersey, one of my dear students. Hey, Lucia.
Oh yay.
I saw
How
my
many we
sister
up
with
to
her
now?
whole group of children and that are watching on the East Coast.
Oh, that's sweet. Athena's on. Hi, Athena.
Oh, wow. The background is pretty great there, Janet, got to say.
Oh,
Pretty
thank you, Bill. It's fun when I'm teaching. It's like sometimes the kids wonder, am I, like if I start kind of like, getting really excited, am I floating in space? But this is a great background I found on Amazon of all things.
Imagine that.
Yeah, 2.4, magnitude 2.4. Hang on, something's loading here.
Okay.
Do you have the epicenter yet?
Hey.
Yeah, this one says Pacoima. If you know what Pacoima is, it's actually in the city of Los Angeles.
Yeah.
For those of you unfamiliar with the city of Los Angeles, it stretches from Mexico to Oregon, technically. No, it's quite large, but in other words, it's right up the street. I mean, and the place shook pretty well. Oh, yes, there's a rocket launch. Yes, greetings. Sorry. Got a little distracted.
Thank you, Bill. Why don't we get started then? Hello, everyone, and welcome to our Mars 2020 launch party. My name is Rachel Lyons, and I'm the Executive Director of Space for Humanity. I'm so excited to be partnered up with the Planetary Society and Helios Capital in celebrating this incredible launch. And I would like to introduce our host, Sarah Cruddas. Sarah is a TV host, author, space journalist, and global thought leader within the new space sector. She has an academic background in astrophysics. She's the host of Contact on Discovery, and we are so grateful and excited to have her as a board of director member of Space for Humanity. Sarah, over to you.
Thank you. I am so excited to be here. I want to start by thanking all of you for coming here and sharing this launch. We are going to Mars today. How exciting is that? The weather's looking good at the moment for launch. We're around T-minus 30 minutes until the Atlas V rocket will be launching with the Perseverance rover and, of course, the Ingenuity helicopter, which is the first helicopter which will potentially be flown on another world. So it's an incredible day just in terms of stepping forward beyond Earth and asking questions, exploring beyond Earth and trying to find out more about our own place within the solar system. Of course, this is the first mission to Mars, which is purely dedicated to astrobiology as its main prerogative. So this rover potentially could get that next piece in the jigsaw puzzle to try and understand, has there been life on Mars in the past? And is there even microbial life there today? So it's a hugely exciting mission. We have got so many incredible guests for you today as well. So if you're joining, particularly from the West Coast of America, thank you so much for getting up early for this incredible launch. And it's such a privilege that we've actually got someone on the ground just a matter of miles away from the launch side. So MaryLiz Bender is the co-founder of the Cosmic Perspective. MaryLiz, how's it looking where you are right now? Can you hear me, MaryLiz?
Yes,
Hey.
I can. You're coming in loud and clear. It is absolutely stunning. It's beautiful here. I am seriously looking straight at the rocket. The sun just rose. As you can see, we've got a telescope that Ryan, my partner, is setting up, and we're going to track the rocket. I've got my telescope behind this camera, so we're going to kind of race and see who can track the rocket the best. This is what we live for. This is our dream. So right now, we've got the countdown nets on. Everything is going according to plan, which is honestly a huge relief and kind of astounding because weather here can always be tricky.
Well, the sky's looking incredible, and I'm so grateful to have someone on the ground today, because this year certainly hasn't been the year many of us have wanted, but to have someone on the ground getting to witness the launch. I mean, I know you've seen quite a few rocket launches in your role, actually reporting on these rocket launches, but how excited are you feeling right now? What does it mean to you?
Oh my God, this launch means more than anything to me. I will say I saw my first rocket launch with Bill Nye, and he is an amazing person to watch a launch with. I got to see the launch of Lightsail, and it's really amazing to be next to the humans that actually made this happen. So why this is so special is I spent the entire last week talking to all of the scientists who will analyze the data, the sample returns that come back, the engineers that actually built the helicopter. We're doing good. Built the helicopter, the rocket scientists who actually built the rocket and made it go, and the engineers of Perseverance, the rover. And then I got to talk to the kids who named Perseverance and Ingenuity, Vanessa and Alex. And this time I'm going to be watching this launch, and I'm going to be super emotional just thinking about those people, all of the hopes and dreams and aspirations and hard work that's lifting off today.
Well, that is incredible. And just to pick up on that, you mentioned you watched a launch with Bill Nye. We, of course, are so honoured to have Bill Nye joining us today for this party, and we'll be speaking to him after the launch and learning more about the mission. So thank you so much, MaryLiz, and I hope we can speak to you afterwards. You seem impossibly excited. I'm so jealous, but thank you so much for being there.
I wish you guys could be here. That's my dream, is to transport people here. So thank you for letting me give you a little window into this universe. Enjoy the launch, you guys.
Thank you so much.
Go Alice, go NASA.
Just an update as well, we are currently looking go for launch. So there's a 10% chance of a weather violation, which means there's a 90% chance that this rocket is going to be launching on time today. So everything is looking good at the moment. Janet Ivey, I can see you there with possibly the best background of all our guests, perhaps only second only to MaryLiz, who might have the rocket launch in her background.
Sure.
Now, you are the president of Explore Mars and founder of Janet's Planet. You have been inspiring so many young people about exploring space, about exploring the solar system. How excited are you about today's launch?
You know, I can't contain it, truly. It's like I feel like my heart has expanded to its maximum. And mainly what I get excited about is the excitement of the kids that I've been working with this past year. We sort of flipped everything, went completely virtual. Naturally in this year that's 2020, and giving kids something to dream about, to aspire to, and all that is perseverance. I do think that Alex Mather had a prescient moment when he sent in that essay, What a Perfect Name, and something that I think we humans can use a bit of in this year is perseverance. But I am delighted, and to me, there's nothing more exciting than Mars, and especially perseverance is paving the way for human exploration. And I truly believe one of my amazing students, and one of them may very well be online with us this morning, is part of the generation that will set foot there on the red planet. And we will begin to see amazing things happening as far as exploration goes in our solar system.
Janet, you know, it's like you read my mind, because my next question to you was going to be, when I talk to school kids, one of the things I always say is that our first Mars walker walks among us. They're probably a kid in elementary school right now. And what is your message to young people out there who, you know, to encourage them to dream the impossible and to realize that they are the Mars generation? They're the ones who are going to potentially make that first landing possible.
You know what, a quote I love to always start off with is from Gene Roddenberry, who says, we are on a journey to keep an appointment with whatever we are. And so that is their mandate. What are we? how are we and where shall we be? And to me, that's like kids get it. All you have to do is sort of use Mars as that entry or a gateway and go, what if, and how would we do it? And you will literally get a dust storm of ideas because this excites them. And I think that we need to give our children, to create that STEM pipeline, we've got to give them this something to dream about beyond their homes, their towns, their communities. How can we make the world better? And I often say, you know what, guys, when we go out there, it's like whatever we discover with how to, like MOXIE, that's my favorite instrument. I'm so excited about that one, that can convert carbon dioxide into oxygen. We come up with fuel and a resource for humans. Whoa, what do we solve here on Earth? What do we solve when we create a space suit that is impervious to radiation? Do we cure cancer back here on Earth? So I like for them to think that there are not only, it's not only Earth, it's not only Mars, that we are thinking as we go out there, we're always got an eye turned around to that pale blue dot that's like, that's home, that's where the good stuff is. And if we can figure out even food scarcity here on Mars, we figure it out back home. So when I give them that kind of like perspective that it is for all humanity, and all the good and all the good science we discover can only benefit us here on Earth, they're like, I've got an idea. And that's what I get excited about.
I think that's probably the most incredible point. It's just, people think about space as going outward bound. And of course it is. It is about extending our presence of life on Earth. But everything we do in space relates back to us and how we can improve life on Earth. So we have now got just over 15 minutes until the NASA launch. I just want to ask you quickly before we cut to NASA, Janet. Is Mars planet B? Is it going to be our backup option, as some people say, or is it a case of having a second planet where humans can go, but not a backup planet?
You know, I don't see it as plan B. I just see it as yes and. Do you know what I mean? I feel like it's an extension of what we will do. I mean, built in us and humans, in our DNA, is curiosity and exploration. We have sort of an insatiable thirst of the soul, kind of to challenge, you know, are the confines of what we know. And I think Mars is a yes and. Its Earth is always going to be this place that has got the perfect conditions. We don't have to don something before we go outside, and we don't have to work so hard in a harsh environment. Or, I don't know, 2020 might prove us wrong, but it's like, you know, I don't see it as a plan B. I think I see Mars as a yes and. And I think we must set our course for Mars, and we have to do it now, just as we're doing it today.
Okay, fantastic. And I think I'm now a huge fan of yours, because that was just hugely inspiring. I'm seeing here it is now less than 6 minutes to go until launch. So we are, on that note, on Janet's hugely inspirational words, we're going to now cut to NASA, and we're going to see a rocket launch to Mars. So we'll be back with you after the launch. Hopefully we are cutting to the NASA coverage now.
Oh, I see. I can see.
And during that time, the whole ULA team, they were all go. We got to hear the third of our 5 teams. The third of our 5 teams. We got to hear the end of that, where the range was clear to proceed, and ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are the fourth team, that they are on internal power, and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, you know, we talk about being nervous and excited. This is right here where we're nervous and excited. Yes. There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The 5th team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, you know, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post liftoff, want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. I want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up there.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FPS
sequence at T-31 seconds. So that's a big thing that they're getting done here. At T-25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
arm.
this mission.
SCS count started.
1 minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Vent valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an important point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5,
5.
4. Engine ignition. 2, 1, 0. Release and liftoff. The countdown to Mars continues. The perseverance of humanity launching the next generation of robotic explorers to the red planet.
Woo!
And Atlas TU has gone to closed loop control.
Go, go, Percy!
Flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic.
Yeah.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
Wow, right on time. Very cool.
Beautiful. I can see the plume from my spot in Orlando.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
That seems pretty fast to me.
And the Centaur reaction control system is now pressurizing to flight levels.
100 miles a minute.
And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
It's rocket science, people.
That it is.
How's everyone feeling right now?
And we have good indication of payload fairing jettison and
Rel-
Centaur
relieved,
forward
Sarah,
load
relieved.
reactor deck jettison.
I'm loving this view.
Woohoo! It's amazing.
Home.
And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
Just think about how many thousands of people
And
contributed
Centaur has
to
begun
that
the boost
launch.
phase chill down sequence to thermally condition the RL-10 for operation.
Yeah, I often think about the history of what
Standing
it
by
took
for
to
Pico
get us
shortly.
to this point in terms of the buildup of engineering knowledge from the first rockets to this one. You know, all
It
the
was,
understanding of atmospheric physics.
because the call
et cetera.
for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation.
So it's a buildup of.
And we have good indication of
years
Atlas
of
Centaur
experience here.
separation.
Indeed. Well said, Livingston.
So there you're seeing live footage.
And we
from
have
the
MES
rocket.
1. RL-10 operating parameters look good. Chamber pressures are stable.
But it never gets old. This never gets old.
This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
Wow. That's a lot of fuel.
Yeah, it is.
MaryLiz looks
So Mick, that's pretty
excited.
exceptional footage there. That's live
Thank you,
video.
MaryLiz.
We will see that switch over shortly
over there,
to
MaryLiz.
an animation that kind of helps let us know.
Is that their launch dance down at the in Florida?
Wow.
Wow. Look at that.
Oh, wow.
We've got 2 views there, the space view and the ground view. There we go.
There you
Love
go.
that angle, Mary Liz.
Beautiful.
Amazing. And we have Alyssa Carson on. Hi, Alyssa.
Hey, good morning, everyone.
Good morning, sweetheart. How are you?
I'm doing good.
Awesome. I got to tell you, there's never a launch that I weep. It's just the stupendous math and science and all of, like, Livingston was saying, just everybody who worked towards this moment. Congratulations, team.
Yeah.
Just.
I think there's a transition point where the historic and repeatability of our engineering work gets to a spot where, you know, we become more and more successful. So it looks normal, it looks routine. But when you think about the physics of what's going on and the challenge of the precision and accuracy and the strength of the systems, it's not simple. Every time an airplane flies, I marvel at the fact that, you know, that's a lot of physics and engineering working in harmony to make it all just work as if it's just normal. But it's a lot of work behind each one. So with this much energy being expended this quickly, you know, it's a controlled explosion, but it's a testament to the work of those who've gone before to make this look routine.
I think, Livingston, we're so honoured to have you today, because you are just a dream with words and just summing up exactly what's happening. And it's if you look back over, you know, one human lifetime, if we go back to 1900, so little more than a human lifetime, and look at how much life has changed, how our world of today is almost like a world of science fiction compared to just one human lifetime ago, and how each mission becomes more daring and complex than the next, and things that we take for granted today are things that our ancestors couldn't even begin to dream of. And it's just so incredible to think that this mission is not only going to Mars, but it's also potentially going to be part of returning the first ever sample to Mars from the planet Mars. And that's just something I know sometimes I myself, you feel frustrated because you think, why are we not on Mars by 2020 already? But you forget how much we've achieved and how we've learned to live and work in space, and all the things that we're building on to make that possible.
This is definitely a buildup, and here's the challenge. We know how to get off the planet. We've got good experience with the types of rockets that you saw launched today. So our knowledge base, you know, we got a LOX kerosene rocket on the bottom, a LOX hydrogen rocket is the upper stage. We've gotten good experience with that. We've gotten good at that. Now, you know, we understand the physics of how to get from Earth to Mars. That stuff's not as hard as it used to be. You know, we can now calculate that with a high degree of accuracy. What we don't have a lot of experience with is landing stuff on Mars, especially big stuff. You know, we only have, you know, a handful of experiences with that. And when you only have a handful of experiences with any engineering system, the risk is much, much higher. So the more you do it, the better you get at it, and the more you learn about it. And Mars is a particularly tough place to land. You know, when Bill and I were talking earlier, I keep asking about, you know, geez, what are things like in that thin atmosphere? Because it is so thin that you can't rely on a parachute to get you down to the surface without crashing, because you will not bleed enough energy. So you have to have some propulsive element or something like that. This is hard. Now, over time, we will figure this out. We'll have a routine. We'll go, you know, this has always worked better. And so we'll start doing that. And then, you know, we'll be able to do it more frequently, more successfully each time, bigger vehicles, larger rovers, larger helicopters. But it's hard right now, very hard.
And I think those are incredible points. And I think to pick up on that, of course, all the scientists and engineers, the many people who've worked on this, they are, of course, going to have this 7 minutes of terror again as Perseverance attempts to land on the surface of Mars, involving a sky crane and all kinds of crazy contraptions to try and overcome that problem of the thin Martian atmosphere. I just wanted to cross now to Michael Lopez-Alegria, who is, of course, a retired NASA astronaut. Mike, you've ridden rockets. How does it feel seeing a rocket lift off bound for Mars?
I have to say, I've seen my fair share of countdowns, and I think it was Livingston that said they never get old. I mean, it's just so much excitement and tension packed into those last few seconds. And when you finally see movement off the pad is a huge sigh of relief, obviously. And it's clearly not over at that point. I mean, when people say that when you light a rocket, 10,000 things can happen, only one of them is good. So luckily what we saw today was good.
Incredible. And then just before we cross over to Bill Nye, I just wanted to bring in Alyssa Carson, who is an aspiring Mars walker. So you represent the next generation and potentially that first person who will be setting foot on another world. As a young person, how does it make you feel to see all this incredible excitement around space and this mission going to Mars?
Yeah, totally. I mean, obviously the launch was completely beautiful today. I had like a secret hope that it was actually going to be moved to tomorrow because I'm actually driving down to Florida tonight. So just one day off from seeing it in person, but that's okay. Nonetheless, it was absolutely wonderful to see it here today and to be able to see, you know, so many more components now kind of shifting to Mars and seeing all the excitement now kind of gathering around Mars. You know, I think in general with Perseverance and with so many other things, you know, the public in general is getting more and more of excited and getting ready to see more things come from Mars, and the more science we come from it, people are getting excited to see that. And so it's really awesome for me to be able to see that and share, I guess, my love for space with now, I guess, more of the general public, because they're finally getting into it. I'm like, oh, I've been into it. You guys are now just catching on.
I love it. I love your enthusiasm. And I just want to take this moment to thank all our sponsors as well for today. So not only Space for Humanity, but Explore Mars, Helios Capital, and of course, the Planetary Society. And with that, tedious link, Bill Nye, I don't even know how to describe you because you are such a legend in terms of inspiring the next generation. So I think if it's okay with you, I'm just going to introduce you as a legend and someone who has really inspired so many people, not only in America, but across the world, about why science matters, why space exploration matters. And we are so incredibly privileged and grateful to have you here today. You are, of course, CEO of the Planetary Society, as well as being a best-selling author, TV host, and an inventor and many other things in between. And I know we're going to discuss the microphone on this mission and the importance of that as well. But I just, first of all, wanted to get your reaction to the launch.
Oh, it's just always amazing. Everybody, you know, I don't know if you've ever been grocery shopping. You make a checklist. When you launch a vehicle like this, the checklists are astonishing. There are millions of line items. As you said, 10,000 things can happen. Only one of them is good. I mean, it's probably a million things can go wrong, and only one of them where it doesn't go wrong is good. It's so complicated. It's so fantastically complicated. And this is why I always say space exploration brings out the best in us. It brings out the best people solving problems that have never been solved before. And to make this sort of mission, this sort of launch, routine or reliable or leave to the second is really quite an amazing achievement. And as Bruce Murray used to say, you know, the people there at the Jet Propulsion Lab and at NASA and at Kennedy Space Flight Center, Marshall, all the places that come together to build a rocket like this and launch it, they're just as good as it gets. I mean, they're just as good as anybody is at anything here on Earth. And this mission for me is especially exciting because it is a key first step in bringing back samples from Mars. Now, if you talk to geologists, and as I like to joke, some of my best friends are geologists, they think that they can tell you who was president by looking at a rock. Okay, that's I exaggerate a little. But they also claim they can tell who's going to be president. I'm kidding. The thing is, when you get a sample of a rock, every rock tells a story. So geologists and geochemists have been very excited about bringing a sample back or set of samples back from Mars for decades. So this mission really is a solid step on that larger idea. And if you like to think about large ideas, is there something alive on Mars? Was there something alive on Mars? If there was, and we can find evidence of it, I claim it will change the course of human history. Everybody will feel differently about being a human being, being alive here in the cosmos. You know, there's no place like home. The Earth is unique and remarkable, and we are especially suited to it. But man, you cannot help but wonder what happened on Mars, let's say 3 billion years ago, 3 billion Earth years ago. What went on when there was an ocean and a thicker atmosphere and it was warmer? You just got to wonder, do living things just happen in the cosmos, or are we especially unusual? And if you
And of
like to
course-
get crazy, I'll finish this part with
Go
this.
ahead.
If you like to get wild, did life start on Mars? Mars got hit with an asteroid or an impactor of some sort, and woo, 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 except there's, as I like to say in space, there's no sound. And this thing landed on Earth, and you and I are actually descendants of Martians. It's really an extraordinary hypothesis that this mission is an important part of investigating.
See, Bill, you read my mind there, because I was going to interject with, what do you think of the possibility that life on Earth could have come from life on Mars, could have come from life on Mars, because of course we know in the past Mars was likely much warmer and wetter.
Well, so Mars cooled off about 1 billion years before the Earth. It's smaller. And so it cooled off more quickly. Oh, by the way, check out the Planetary Society website. We have our educational materials up there where we encourage you to do a which planet cools off faster, an Earth or a Mars experiment. So that said, because it cooled off faster, it got an ocean faster, it got a thick atmosphere faster. And so if life was going to start, it's very reasonable that it started on Mars about 1 billion years before it had a chance to start here on Earth. And people throw around the word billion all the time. Billion this, a billion that. It costs $1 billion, a billion years, whatever. So if you count to 1 million, takes you a little over, staying up all night, counting 1 a second, you can do it in 11 3/4 of a day, okay? If you want to count to 1,000 takes you 20 minutes. To count to 1 million takes 11 days. To count to 1 billion takes you 31 years and 8 months. It's just really the amount of time in 1 billion years is literally hard to imagine. It's probably literally impossible to understand. And so if you have something going on for 4.6 billion years, a lot can happen. And this mission is part of this. And I remind everybody, I'm in the U.S. I'm a voter and taxpayer here in the U.S. But this mission involves everybody in the world. There are instruments and engineers, scientists from all over the world involved in this. And the amount of money spent on a mission like this is tiny because it's spent over 20 years. And all the money that's spent in space, as we like to say, is actually spent on Earth. Wait a minute. That's right. All the money spent in space is spent on Earth, and this mission may help us make a discovery that will, and I say this all the time, change the world.
And I think that's such a profound thing. We have a lot of time with you. We have another 10 minutes with you, which is a huge privilege, because you are just an inspiration to talk to. But I wanted to talk about the instruments, and we talked offline before about how images have changed our perception of the universe, and in fact the views of our Earth from space have had a hugely profound impact on humanity that you perhaps cannot measure. But of course this mission has a microphone on it, and this links back to one of Carl Sagan's visions as well. Yeah.
So everybody, just to give, for those of you who for some reason are not members of the Planetary Society, please check us out at planetary.org. But to give you just a little background, Planetary Society was started by Carl Sagan, Bruce Murray, who was the head of the Jet Propulsion Lab during the heyday of the Voyager landing, the first landings on Mars in 1976. And on July 4th, the anniversary of the U.S. Constitution being ratified, and then Lou Friedman, who was an orbital mechanics guy at the Jet Propulsion Lab back then. So anyway, the story goes that Bruce Murray, as a young guy, was in meetings about the Mariner spacecraft, which were headed to Mars, the same Mars that we're going to right now. And by all accounts, he was the guy pounding his fist on the table saying, we got to put a camera on this thing. This mission has to send back pictures. And by all accounts, people at first poo-pooed this idea, like, oh, pictures, that's just a publicity stunt. There's no science in pictures. We can't. But he went on, and by all accounts, he made the case that there's valuable science in pictures. And of course there is. I mean, we all acknowledge that now. But furthermore, can you imagine a space program without images? I mean, people around the world will just not be as engaged in this undertaking as we all are, because the pictures are astonishing and spectacular. And something that has struck me about Mars, every time I've seen pictures, I'm of a certain age where I remember very well when Viking missions landed on Mars. I was a grown-up. I was in college. Anyway, Mars is a place. Like if you were dressed properly, you know, like a spacesuit, let's say, you could walk around and have a picnic. It's amazing. It's so much like the Earth in so many respects, but then, of course, so different. Anyway, on this mission, there are 2 microphones. Now, Planetary Society founders and members have been talking about microphones for years. I was on stage with Buzz Aldrin in 1999 when we had a microphone going to Mars on Mars Polar Lander, which was going to land on the South Pole of Mars. And by all accounts, it did. It just crashed. And so the microphone is presumed to be in the wreckage on the South Pole of Mars. And so we never got the sound back. But this mission is going to have a microphone on entry, descent, and landing. We presume we're going to hear the wind rushing by and the opening of the supersonic parachute and the retro rockets and so on. And then it'll have a microphone on the surface. And this is something that Carl Sagan wrote about in the 1990s. That, boy, if you just had a few minutes of sound from Mars, it would inspire people around the world. And it will. It will give us engineering information about the spacecraft. What do the motors sound like in the extreme cold, very thin atmosphere? What do the wheels sound like cranking over the Martian surface, the regolith? But the other thing, it will inspire all of us. When you hear sounds from another planet, we will feel differently about that other planet. We will feel a kindred nature. We'll have a kindred spirit is the word everybody likes. We'll feel more attached to Mars because it's a planet so similar to the Earth and yet so different. And I remind everybody that climate change in the modern era was discovered by studying Venus, Mars, and the Earth and comparing them. And Carl Sagan talked all the time about comparative planetology. So when we study Mars, we learn about the Earth.
And we're getting a lot of comments in about Carl Sagan specifically. And I just wondered, specifically about this microphone, do you think Carl Sagan was ahead of his time?
He was part of his time. He changed the world. When you say ahead of his time was shaped by his leadership. He was so well-spoken. He was so thoughtful. He's a poet. When, I'm of a certain age, if you got this story, I took one class from Carl Sagan.
I remember.
And it changed my life. The guy inspired me. And his legacy is with us today. The Cosmos series is in its 3rd manifestation because of his insights. And just this idea that we are part of the cosmos. It's really remarkable because it means that, as Carl Sagan used to say, we are made of star stuff. We are made of stardust. And so that means that you and I, all of us, are somehow one way that the universe, the cosmos, is aware of itself. And if that doesn't fill you with reverence, I mean, what does? My goodness, people. You and I are made of the materials of exploded stars, the elements on the periodic table. The elements on the periodic table come from exploded stars. And so you and I are part of this greater thing. And so a mission like this today helps us know the cosmos and our place within it. And there are 2 questions that we each ask. And that is, where did we all come from? Where did we all come from? Really? Come on, people. How did we all get here? And then, are we alone? If life can start on the Earth and life could perhaps have started on Mars, does it start all over the place in the cosmos? And we are part of this larger, gigantic, almost unimaginable awareness of the cosmos. And it's just an amazing thing. It's just an amazing time. And to discover evidence of life on Mars it'll change the world. It'll be like Copernicus or Galileo making these amazing discoveries, except, as everybody's been talking about earlier, it won't be one person who makes this discovery. The discovery will not be attributed to one man or woman. It will be this team, this group of engineers and scientists who achieved this, and they were funded and supported, and the organization created by voters and taxpayers, by people who just think this is a worthy use of our intellect and treasure. And so everybody, this is really, people throw this word around, but we're not kidding. This is an historic day.
And Bill, you talk with such inspiration. I think when I speak for everyone, like what you were saying, it literally gave me chills, and it's so important. I just wondered, what inspires you most about space and our space future?
Well, just that I'll tell you what, the thing about science that I find so compelling is the premise, the idea, the fundamental notion that the universe is knowable, that there is a way to understand the cosmos. There is a way to compare one planet to another. There is a way to investigate the nature of life, living things, and to investigate our minds, our brains, and to understand why we wonder about all this. And so space exploration is sort of the greatest manifestation of that idea, that the cosmos is knowable, that our place among the stars can be figured out. And furthermore, by figuring it out, we get better at everything. And by everything, I mean living. You know, we have, yesterday, I'll just talk some more about me. I recorded a podcast with Jane Fonda on Science Rules, we call it. And she talked about when there were 2 billion people in the world, when she was born in the 1930s. Well, now there's 7.7 billion people in the world. And for the most part, there's a lot of trouble, to be sure. But for the most part, we feed all those people. And we do it because of science, because of our fundamental understanding of agriculture, understanding of life science, or understanding of water and irrigation and weather. And that all comes from studying our planet and comparing it with other planets. And I'm not kidding. It's just an amazing time. As we say, if you couldn't pick where on Earth you would be born, but you could pick when, this would be the time to be born. As messed up as things might seem from time to time, things are better now for more people than ever before in human history. And that's because of science. That's because of our understanding of nature and our place within it. And the most recognizable image to anyone in the world is that image or an image of the Earth from space, where we realize the Earth is a planet. And it's round because of gravity, and it looks a little out of focus because gravity's holding this atmosphere on it. It's just an amazing time to be alive. And this mission today is part of this larger drive for all of us to know the cosmos.
That's absolutely fantastic. And what is your hopes for the future? Do you think maybe this sound we get from Mars, from Perseverance, do you think that could change our perspective of the cosmos in the same way that images have?
Well, here's what I'm hoping. The sound will inspire everybody to send the next mission and the mission after that. That's what we need to bring these samples back. And the more missions we send to Mars, the more we'll know about Mars. And my big thing is I want to find evidence of life in my lifetime. I mean, that's what I want. I want to look for evidence of life on Mars. And this mission, as you all were talking about a little while ago, has this enormous and vital astrobiological component. Just the word astrobiology, that was coined in my lifetime. No one threw around the word astrobiology when I was in elementary school, grade school, primary school. And so just that we have that word is a reflection of a cosmic perspective that is enabled or produced or a result of space exploration. I mean, this It's just amazing. This is on Mars, everybody. Do you know how hard it is to get to Mars? You can only go every 26 months because the planets are moving. And then when you get there, you're going so fast, it's really, really hard to slow down. And then to try to get from going really fast to land on the surface without just destroying everything, your spacecraft, is just not easy. And yet we're pretty sure we're going to pull it off again. It's a very exciting time, everybody. It's a historic day.
And of course, thank you so much for your time on this historic day. And for anyone around the world who wants to get involved, you are, of course, the CEO of the Planetary Society, who are working with us today. How can people get involved with the Planetary Society, and why should they?
Well, the Planetary Society is at planetary.org on the electric internet. The internet is a result of space exploration. We would not have the internet without space exploration. Anyway, as we like to say, if you like birds, you'd probably join the Audubon Society. If you like the environment, you might join the Sierra Club or the Environmental Defense Fund or something like that. But if you like space, join the Planetary Society. We do three things. We, at least, we educate. We have outstanding journalists. You can read long-form articles about planetary missions that you will not find anywhere else. We innovate. We have a spacecraft flying right now, the first solar sail able to maneuver in Earth orbit, to tack and increase orbital energy in Earth orbit. It's flying right now, and because it works so well, it hasn't burned up. And check out the amazing pictures that we've been able to send down over the last few weeks because of these engineers and scientists who've been very diligent about the software. Oh my goodness, these pictures are amazing. They give you the overview effect that astronauts talk about all the time, where you look at the Earth from space and you go, my goodness, we are all in this together. There are no political boundaries. This is our home. And then the third thing is we advocate. We go to government representatives around the world to encourage investment in planetary missions, because planetary missions are where we make these astonishing discoveries, where we make these new discoveries about the cosmos and our place within it. Both missions like this, where we're going to the surface of a world or looking at a specific world nearby, and at distant worlds. Another word that was coined in my lifetime is exoplanet. Nobody had the word exoplanet when I was in secondary school. It just didn't occur to anybody. And yet we have all wondered about it. Furthermore, when I was in college, Frank Drake was also there, Cornell University. And the Drake equation was he created, when we'll just thinking out loud, thinking carefully about the cosmos. Well, people speculated that there might be a planet around, let's say, 1 in every 100 stars. Well, now people are pretty sure there are about 10 planets around every star. So that is 1,000 times more planets than was speculated even 4 decades ago. So you guys, everyone listening, audience members, this is what the Planetary Society does, is investigate the cosmos, investigate the possibility of life elsewhere, to learn more about ourselves and to learn more about the universe, where we all came from and whether or not we might be alone. Just check us out at planetary.org. And I want to thank you so much for letting me go on about our little, our merry band. We have 50,000 members around the world. We're growing. Please check us out. We are outreach partners on this mission. And we are very excited about next February when we land on the surface and get those first pictures and those first sounds. It's going to be fantastic.
Well, thank you so much for your time, Bill. And thank you so much for all the inspiration. I think what you've just said there, and I love the notion that when you go out and look up at the night sky tonight, not only is there a little extra piece of humanity up there in Perseverance, but for all those stars you see, there are other solar systems, there are other worlds.
And right now, Neowise, the comet, is going out, but away from us. But Mars, rather Jupiter and Saturn are quite visible right now. And the other thing I should mention, doggone it, at the planetary side, we're very active in planetary defense. When I was in college, Carl Sagan talked about the Tunguska event, which is, now we use the term airburst, over Siberia that knocked down trees 100 kilometers in every direction. As we say, an asteroid impact here is a very low probability event, but with enormous consequences. It would be, as the joke goes, Control-Alt-Delete for civilization. So the Planetary Society works very hard in planetary defense. We fund amateur astronomers around the world who track asteroids, and we're very supportive of the NEO-WISE mission, after which this comet NEO-WISE was named. So everybody check us out at planetary.org. And I want to thank you again for letting me go on about us. We're like-minded people around the world who are advancing space science and exploration.
Well, thank you so much for your time, and it's been great to find out more about the Planetary Society, and I think everyone is honoured to have you speak here today and to inspire people. So I'm giving you the what is that signal? That one back. Well, Bill, thank you, and thank you to the Planetary Society for partnering with us today so that we can bring you all these incredible people. And I'd like to welcome now two other incredible people. So Rachel Lyons, who is the Executive Director of Space for Humanity, and Dylan Taylor, founder of Space for Humanity, and he's also the CEO and Chairman of Voyager Space Holdings. Rachel and Dylan, how did you find that launch?
Oh, remarkable, Sarah. I mean, I'm inspired every time I see a launch, and I just want to acknowledge Bill and his remarks, hugely inspired by what he just had to say. And, you know, it's a great day for humanity. I mean, it really is. These are the kinds of moments where I think we all crystallize in our minds how important it is to be flying in formation and in coordination. And I think about all the hundreds and thousands of people who've worked on this mission, and I'm just truly inspired at what humanity can pull off when we all work together for a common cause. So I'm feeling amazing, and really excited for February when we actually get to Mars.
And of course, Dylan, you founded Space for Humanity, which has the goal of democratizing access to space, which essentially means we've been sending the same type of people to space. To date, fewer than 600 of us, of the more than 100 billion humans that have ever existed, have actually made that journey, and they've been the same type. They've generally been military personnel or scientists, but the aim of Space for Humanity is to, and it sounds like a dream, to be honest with you, it's to send people from a whole range of backgrounds on flights to space as a spaceflight participant. Can you just tell us a bit more about what inspired you to found Space for Humanity and that mission?
Yeah, sure. There's really two fundamental concepts. The first is that space is for everybody. As Bill said earlier, space is really the best of us. It brings out the best of us. And so as we venture into the stars, I think it's really, really important that the entire world, the entire 7.7 billion of us, feel like we're part of this spaceship Earth and part of this mission to venture out. So first and foremost, it really is about democratizing space. But the second fundamental concept that the organization is based on is that space really is a tool for transformation. If you think about a lot of the problems we have on Earth and a lot of the challenges we have, my view is those are intractable or appear to be intractable because we don't really have the right mindset or the right context. And I think if space is anything, it allows us to reflect back on ourselves. And I think that's a very powerful context. It's a very powerful viewpoint that can not only change minds, but change behaviors. And ultimately, I think take humanity to the next level. And that's fundamentally what inspires me is how do we transform humanity for the better? So those are really the two things that the organization was founded on. And I just want to acknowledge Frank White, who I know is on the call. He coined the term the overview effect. I'm a big believer in the power of that. And so we want to get more people into space. We want to get more people engaged in the mission that is space. And we want to elevate humanity and show how powerful we are when we work together. That's really what it's all about.
That's great. And I would just echo your sentiments also about Frank White, a true inspiration. And it is that it took scientists and engineers to get us to space, but we need the philosophers and the communicators and the thought leaders to actually explain what we see when we're in space and the impact it has on Earth. Rachel, I just wanted to bring you in as well as Executive Director, just to so we can explain to all of you watching, because there's so many of you, which is incredible, how you can actually participate in the work of Space for Humanity and potentially get involved in one of these spaceflight trips.
Yeah, definitely. So we take applications on our website. They're currently closed, but we will be reopening likely next year for people who want to take this trip to space and they want to use that trip to make an impact in their communities. So like Dylan was saying, we want to seed people all around the world to go and to spread this perspective that Bill was talking about, this perspective that Dylan was talking about. There's other ways to get involved in the meantime. We're going to keep doing these launches. They've been so much fun. It's been an amazing way to spread the word. We'll be launching a talk series and just a number of different educational initiatives. So people can go online, they can look at volunteer opportunities, they can also contribute and stay up to date, because we will keep rolling these out.
And of course, Rachel, you and I have known each other for a few years now with our work for Space for Humanity. I think it's fair to say you've become a real rock star in terms of driving forward this organisation and just inspiring as many people as possible about why Space for Humanity's mission so much. And also, you're a young person working in the space industry. What does it mean to you to have this role, to potentially transform what it is we do in space and who can go to space?
Mm-hmm. Thank you, Sarah. It's been so incredible to have this role. And I think the biggest thing that I've been present to is that me working with this organization for almost 3 years now, I'm constantly thinking from this global perspective and constantly having conversations about the overview perspective and about the fact that we all live on a planet. And it's training my brain to continue to think like that. And so that's why with the content that we're pushing out and the work that we're doing, I think that the more people familiarize themselves with this mission, the more they'll be able to just think from this perspective. And with that, we can treat other humans with more love and respect, and we can treat our planet with more love and respect. And I just think it is a world-changing mission, and it's the first of its kind. So it is such an honor to work on. Dylan, thank you for founding it. Thank you for your vision. And Sarah, it's been such a pleasure to work with you as well.
And what would your advice be for any young people who want to be, because we've got a lot of young people watching today, which is incredible. And what is your advice for anyone who wants to be involved in the space industry?
Two things. One is keep learning and find what it is that lights you up about space. Because for me, I thought it was going to be, I have a degree in aerospace engineering, so I thought it was going to be helping build the rockets that we just saw launched. But then when I discovered the overview effect, I realized it was about perspective. And so for the people listening, the young people, definitely keep learning, and then also keep networking. Go out and meet people, send people emails, and tell them what you love about what they do. And those who respond and get back to you, it very often can turn into something meaningful.
Fantastic. It's great words of inspiration. I just want to cross over back to Dylan very quickly. Dylan, you're again one of the real, many people may not know you, but you're one of the driving forces in terms of this new space era, and you're a huge figure within the commercial space figure. I mean, what does it mean to you to see how space is changing right now?
Well, I don't know who said it earlier, but it is interesting. I hear from long lost friends who are suddenly space aficionados. So I think it's funny. I think we've really captured the imagination, and I think space is really getting traction in society. And I think it's really a matter of capitalizing on that. And by that, I mean, we need to show the value, not only of these missions that we're sending out, but we need to continue to inspire and engage and make sure that everyone is on board. The commercial space piece is really important. I know we're going to hear from Ryan and George here in a moment, because one of the things that I think is really important for the sustainability of space is that it has some economic drivers behind it. It can't just be a nation state activity. It has to be a commercial activity fundamentally if we're going to really grow the industry the way we need to. So that's where I've been focusing most of my time. And of course, Rachel is doing an unbelievable job leading Space for Humanity. And again, I just want to acknowledge you, Sarah, being one of our board members and really adding a ton of value as well. So thank you so much.
Thank you so much for that, Dylan. And also, I feel like this is a really great link because we are so privileged to have Ryan Kriser with us, who is from Helios Capital, again, one of the partners in this event and a fellow board member of Space for Humanity, and also George Whiteside from Virgin Galactic. So, George and Ryan, I just want to first of all get your reactions on the launch today.
Absolutely amazing launch. Thank you, Sarah. It's truly inspiring to see another rocket lift from this planet and go to another planetary body within our solar system, really sort of paving the way for human exploration, which is going to be coming next on Mars. So, you know, I'm just truly inspired, and thank you to everyone who put this launch together today.
And George, I just wanted to add in congratulations as well, because the new interior for Virgin Galactic looks absolutely out of this world, excuse the pun.
Nice.
See what I did there?
Yeah, thanks. Yeah, no, it's good. I think it's terrific. I mean, the JPL team and the ULA team have got it dialed in for these Mars launches. It's incredible. I think what's, you know, and I mean, to me, what's really inspiring, and I'm sure this has been discussed, is the fact that there are 3 different countries going, and there was almost Europe as well this cycle, and that's really exciting. The spread of the capability is just really exciting, and I'm sure more and more countries will be doing over the coming years.
I think that's a really great point, because I think when we first started going into space, it was the preserve of 2 superpowers, the USA and the Soviet Union. And as you mentioned, you know, we had China and the UAE, and now the USA launching to Mars. So space is truly becoming global, but not only is it becoming global, but it's also becoming about the entrepreneur. So just as in the history of exploration on Earth, we had governments go first and then private industry follow. And now we're seeing the same with space. So space is, what we're doing in space is no longer something new. It's something that we've done on Earth before. But obviously, George, you're doing incredible things at Virgin Galactic. I'm so excited for the first crewed flight with tourists on board. Just how significant is it to have public-private partnerships and private investment driving us forward in space? Why does entrepreneurship and private ideas and businesses matter when we explore?
Well, I think you know, probably all the people on the webcast today and all the audience members, you know, we want to have a really ambitious future in space, right? We want to be sending probes all over the solar system, and we want to, you know, have hundreds and eventually thousands of people fly into space, and all that is dependent on technical progress and innovation, right? And the private sector can do a really great job of that in partnership with the government. And I think the U.S. Civil Space Program and the military side as well, but particularly the Civil Space Program has done a really great job of having a partnership between public and private. And the results speak for themselves. You know, like we've got all these launch companies, we've got, you know, launches going up all the time now, and small satellites circulating, you know, all over the place. And that's a sign of, you know, a really vibrant industry, and a sign that ecosystem between private players and the government players is working pretty well right now. And hopefully we can keep that going.
And I have to ask you, what can we expect next from Virgin Galactic?
Oh, well, you know, next thing is to do a powered flight from New Mexico with a couple pilots in the front. And then we're also going to be unveiling our training area for the customers, but the main thing is some flights from New Mexico.
Incredible. And Ryan, just to follow up with you as well, because you represent a different type of person in the space industry, and that's, I guess, what today is all about as well, because space is no longer just the preserve of scientists or the military, it's the preserve of all of us, and we need all these different skill sets. What has motivated you as someone who's an investor and an entrepreneur to look to space, to look to the stars, and why do you think your type of skill set matters so much as we move forward in space exploration?
Well, it's actually quite amazing, and Bill was talking about it before, how he took a class and Carl Sagan inspired him, and then in turn, you know, Bill Nye inspired me as a young student growing up, and then, you know, getting into the private finance and investment world, I realized that I could combine those skills that I had in business and finance with space exploration. And in order to sort of take humanity to the next level, by providing this economic value and showing that there is the economic value and there's this commercialization aspect to space, you have all of these other ancillary products and services that come into the market, whether it's bioprinting human tissue or 3D printing human habitats on Mars, all the way to having gas stations in orbit. We invested in a company called Orbit Fab, and of course companies like Virgin Galactic, and congrats to George and the whole Virgin Galactic team, and they really sort of were the catalyst for this inspiration to inspire this next generation of both entrepreneurs and investors. And not everyone is a billionaire like Elon Musk or Jeff Bezos. So what I do is I look for founders and entrepreneurs that have equally brilliant visions and ideas, and I help them take it to the next level. But again, just truly inspired me growing up, and seeing Virgin Galactic and SpaceX was another sort of layer to that inspiration.
And obviously we've seen the Mars launch today, which was incredible. But what, the goal is, I think really the next step for humanity, obviously we want to move forward to the moon, not go back to the moon, as some people say. So we want to return to the moon, move forward to the moon, and stay there sustainably. But the long-term goal, certainly within the next few decades, perhaps sooner, is to see human boots on Mars. What role do you think the private space industry can have in enabling that to happen, and how vital do you think the private space industry is going to become?
It's going to be absolutely crucial. I mean, the private investment into a commercialized sector creates competition. It drives the best of us to create the best innovation. And when we're talking about having a self-sustaining ecosystem, we need all types of people from all walks of life working on all different types of applications in order to make that a self-sustaining ecosystem, whether it's construction or resource utilization or infrastructure for H2O and self-habitation, all the way down to people who need to clean and feed us and take care of us. All sort of part of that larger ecosystem that's going to drive this commercialization aspect.
I just think it's incredible how commercial space is actually shaping our space future. I'm a huge fan. I think we really need all kinds of skill sets and everyone on board. George, I just wanted to cross to you for a final word, because obviously Virgin Galactic is one of the leaders in the commercial space sector, certainly a public face of it. But the gift you're really giving to people isn't so much space, but it's Earth and a new perspective on Earth. Can you talk us through how important that could be and how that could potentially shift perspective and life on Earth?
Yeah, absolutely. I mean, I think that is the primary thing that I hope that we can do as a company, is to, as Dylan was saying, send up hundreds and eventually thousands of people into space and to see our planet, which is supposed to be pretty awesome. And, we had our chief astronaut instructor, a woman named Beth Moses, fly in the back of our vehicle to space last year. And it was the first time that she'd been to space. And I view her as sort of like the test case of like, how awesome is it, and she reported indeed it was, the most amazing sight of her life, and I think to be able to step outside of our home planet, even briefly, and to look down and to see, the fragility of our atmosphere, the thin nature of our atmosphere and our ecosystem, and just the beauty of our home planet in a vast, inky black space is a powerful thing. And I hope that our future astronauts come back from that experience changed, and then can share that experience with people in their communities. And we have some programs which will enable them to do that. And I think that's going to be really powerful. And hopefully we can also fly a wide range of people, not just people who are maybe buying tickets, but other people who can, maybe there's a new structure that allows other people to fly. So, so, I think that's going to be really cool. We're going to go from a time when most people haven't known an astronaut, to a time when most people on Earth do know somebody who's been to space. And that'll be a profound shift over the next, 10 or 20 years. And we'll look forward to playing a part of that.
And what does it mean to you on a personal level, George, to have this involvement with Virgin Galactic?
Oh, I mean, I think, I really think, and I've always thought that humanity's expansion into space and helping to find life potentially beyond, who knows, or bring life to beyond, is one of the most profound opportunities that we have for being alive at this moment in time. Aren't we lucky? Like, we get to participate in this great exploration. And so I think it's wonderful that people in this community, people on the line, have the opportunity to participate in this incredible moment when humanity starts to explore the cosmos.
Well, George and Ryan, thank you so much for your time, and thank you so much for all the incredible work you're both doing really in driving forward this new space sector. And it takes so many people from across the planet, from across different industries to really take humanity beyond Earth. So thank you so much for your time, and thank you so much for joining us today.
Thanks for all you're doing, Sarah. Appreciate you. Okay.
Now, oh my gosh, we have so many people still. So thank you for all of us for joining us today. Here to find out more about the mission to Mars are two incredible scientists. We've got Dr. Sian Proctor and Dr. Tanya Harrison. So Sian is a geoscientist, and Tanya is a wonderful friend of mine and a professional Martian, which I just think is the best job title in the world. So you guys were obviously watching the launch. I have to get all your reactions. I know we've asked this to all of you, but how did it feel to see Perseverance and Ingenuity launch bound for Mars?
Well, it's amazing to finally see this happen, to have it happen exactly on time, and just to see how fast that Atlas V just shot off the launch pad. But I've never seen a launch that fast.
I know. Yeah. It was amazing. You blink, you miss it. But it just makes me think we're one step closer to human footprints on Mars with every launch like this.
And I have to compliment you both, because I think you've got the best backgrounds at the moment. So, Sian, this is a Mars analogy background, is that correct?
Right. It's the high seas habitat on the Big Island of Hawaii. It's an analog astronaut research site. And I lived in this dome for 4 months investigating food strategies for long duration spaceflight for NASA back in 2013. And so proud to say I was the first one to live in that habitat with 5 other crew members.
So for everyone watching at home, you are a NASA astronaut finalist, which is a huge achievement. And you're also an analog astronaut. And that's what you were doing living on there, because I think so much of what we do in space feels like it's up there in space, but actually we have to do things on Earth to understand how humans can survive in space.
Absolutely. There's a lot of people around the world who are seeking space here on Earth. And what I mean by that is that we are researching and living as analog astronauts in habitats like the high seas. And the reason why is to get some of the barriers to humans on Mars, things like psychology and crew cohesion and just how to get systems to work. And so you think about when we send a rover like Perseverance to Mars, a lot of testing happens here on Earth to get it right before we send it to Mars. Well, the same thing has to happen for humans. We have to get a lot of things right here on Earth so that we can be more successful when we go to the moon and Mars and beyond.
Now, there are a lot of people, as I touched on earlier, who are kind of like, why are we not on Mars now? I remember I'm a kid of the 90s. I remember growing up thinking 2020, that would be the year that human beings walked on Mars. And obviously, we haven't got there just yet. Just how complex is it? You know, how many challenges do we still face in terms of getting humans there?
Oh, there are so many challenges. And you got to keep in mind that the furthest we've gone is the moon. And so the further we get away from the Earth, the risks go up exponentially. And not only that, when we talk about, we've got the successful launch, but the landing on Mars and how we've heard how complicated that can be. And so when you think about putting humans there and the size of the rocket and lander that we will need to bring humans there, but also the infrastructure that we'll need for them to be able to survive and thrive there on Mars, and then getting them back. And so the fuel, being able to have that, all the resources. And so it's just this grand challenge. But what's great about it is that as we solve for space, we solve for Earth. And so all of those things, as we slowly tick off every one of those check boxes of figuring out how to take carbon dioxide and pulling oxygen out of it, and figuring out how to land in a smaller elliptical circle, and all of these things, that just sets us up for sending humans there. But all that technology and all of that knowledge just helps us become better here on Earth.
And what was it like for you living in that Mars analogy? Like, because that probably gives us you're probably the closest we've got to a Mars walker, right now on this panel, and potentially on the planet. What was it like living there? Like everything from psychology to day-to-day life.
Oh, it was amazing and also challenging. And so one of the things that you've got to think about is when you're isolated in these confined small spaces and going outside, we always had to have a spacesuit on. And one of the things that I noticed after being there for 4 months is how much you miss things like wind on your face. And so little perspectives like that. And so when you think about going to Mars and the psychology of how different your life experience will be, those are some of the things that these types of simulations help us figure out. And so what's happening now with COVID is, to some extent, we're all like analog astronauts. We've had to isolate. We've had to stay at home. We've had to mask up. And how weird it is to go and travel and to have this kind of barrier now. And so these are some of the psychological things that you can begin to think about while you're at home. And to some extent, we're all analog astronauts. And this is how you can prepare for your journey in space, your eventual journey.
I love that. I think that's the best analogy. Just finding the silver lining in the cloud that has been 2020, that we are all living like astronauts. I think you've really hit the nail on the head. We'll come back to you in a second. I just wanted to bring Tanya back in to find out more about the mission, because Tanya, this mission is hugely exciting in terms of astrobiology. And I was just wondering if you could talk us through some of the main objectives of this mission, and also the landing site and why that's so significant.
Sure. So the main goal of this mission is to search for signs of ancient life. And this is a big shift for NASA, because we've been following, follow the water and then look for signs of habitability with Curiosity. And now finally we're going back to looking for signs of ancient life. So Perseverance is not designed to find extant life that might still be alive on Mars today, but it's going to collect these samples in little tubes, cache them on the surface, and then a future mission will come and get those and bring them back sometime around 2031. And then we can analyze those samples in a lab here on Earth to see if we can find any signs of ancient life. We're going to do this in a site called Jezero Crater, which we think used to be an ancient lake about the size of Lake Tahoe about 3.5 or 4 billion years ago. And we can tell this because there's a delta inside of this crater. And deltas form when you have a river that flows into some kind of standing body of water. On Earth, Louisiana is a really good example. Most of the southern part of Louisiana is the Mississippi River Delta, where it flows into the Gulf of Mexico. And when you have that stuff flowing in a river, it hits to this point where it's not flowing very quickly anymore, and it settles out onto the bottom of the lake. And then you just have all this stuff building up over time. And it's a really great place to preserve signs of life, because if you have any algae or bacteria or anything like that, it gets squished in all the layers of that delta. And so we're going to drive Perseverance up to the delta and hopefully take some samples there, as well as along the floor of the crater itself, because you should expect some lake sediments there as well, and see what we can find.
And what does it mean to you as a professional Martian, as a Mars scientist, to see a mission like this lift off today, and all the potential stuff, all the potential science that could come from this?
It's really exciting because we've never been to this particular type of site on Mars. For Curiosity, one of our top 2 landing sites was a delta, and we ended up going with Gale Crater. So now we finally get to go to a delta. And having the chance of bringing samples back where we actually know the geologic context of where those samples came from is really exciting. We have pieces of Mars from Martian meteorites, but we don't know where on Mars those came from, and they've been altered from the shock of the impacts that launched them off the planet and all the way to Earth, and then they've been sitting here on Earth for millions to billions of years before humans found them. And so we don't really know much about specifically, what they can tell us about Mars in a single area or Mars as a whole. We're just getting these little out of context pieces. So finally, we're going to get pieces that we know exactly where they came from. We have the data from the rover to give us a little bit of local context. And then we have the data from all of our orbiters giving us the more regional and global context of those samples. And so hopefully that's really going to revolutionize our understanding of Mars once we get all of those pieces together.
So it's almost like kind of gathering pieces in a giant jigsaw puzzle to try and put it together to prove this extraordinary claim that life might have existed on Mars or may still exist.
It is a very slow to put together jigsaw puzzle.
Maybe it's one of those super large ones. And just, I have to ask you, because it's not just Perseverance going to Mars, it's also Ingenuity, the helicopter, the first helicopter to fly on the surface of another planet. What is obviously it's a tech demonstration, but what is the potential from having an airborne vehicle, a UAV, on another world? What could we potentially learn?
So right now, when we try to navigate the rovers, it's kind of a slow process. So we'll drive a little bit, stop, take a 360-degree panorama, kind of figure out where the lay of the land, and then plan routes from there. But that's slow, it takes a lot of data, and we have the technology now for autonomous navigation. We have it in cars. So now we can take some of that and apply it on Mars. If we have a drone that can fly ahead of the rover, figure out what the landscape is like in kind of near real time, that can help the rover make some of those decisions about where it's safe to drive, or it can help the rover planners here on Earth pick a better route just from what we're seeing on the ground from the rover. We're also getting this aerial view that's much higher resolution than what we have even with, say, HiRISE on the Mars Reconnaissance Orbiter. So it can make driving quicker, it can make our science more efficient, we can hopefully get to more targets of interest in a shorter period of time. And so the benefits are huge. And then it also gives us a little bit of information about the atmosphere higher than where we have with the rovers. And so you get a little bit of science with the helicopter as well.
So a huge amount of science to come from this mission, and combining the findings from Perseverance and Ingenuity and all the other missions which have come before it, and then also the work that people such as Dr. Sian are doing as well. It's just really helping us to push forward into space. I was wondering if both of you could just stay with me at the moment as I now bring in the incredible Livingston holder. For those of you who were watching our Demo 2 coverage back at the end of May, Livingston, you were just an incredible inspiration to talk to and to listen to. And I was wondering if we could start by stating the obvious that 2020 hasn't been a great year. And yes, we are pushing forward into space, but there are also problems on Earth. And if we want to succeed in space exploration, that it has to be for all of us. And if we want to continue to explore space, we have to be inclusive of citizens on Earth.
Yeah, one of my observations is that we as a human species do our best when we work together, and we work together when we work on space. If you look at this mission, the mission that launched from Tanegashima with the UAE spacecraft headed to Mars, those are collective multinational, international activities. And it takes that type of collective to be successful, but it also shows where we as a human race do our best work together. The lines of politics seem to get muted when we try and explore space. I've had a couple of opportunities working International Space Station early in my career, and more recently with some folks from UAE. But that's where we do our best work. And beyond the overview effect, perhaps that can help us work side by side across, I'm an engineer, so we work across our engineering drawing, so to speak, to solve a tough problem, and we get to know each other as people, and we start to connect across humanity. So I think that's one of the more important things about these types of missions, is that it forces us to solve hard problems, and we do it collectively as a planet. And the second point I'd make is that when we do these missions, young people get excited. And I think it's very, very, very important that we transmit what we've learned about not only the science, not only the engineering, but about the relationships across borders to our young people, so that we don't think of ourselves too much in this corner or in that corner, but we realize that we have a reach that expands across the planet to one another, where if we have common interests, we can bring those together. So space is a bridging function across generations and across the entirety of the planet. So I think it's important that that we continue to leverage both the link to the youth as well as the link to each other through missions like this.
And Sian and Tanya, if you just wanted to pick up on that as well, what more do you think we can do to make sure that space is about everyone and that it is inclusive? And are we doing some things right now?
Well, I'll say that it's all about connections, and Livingston was absolutely correct. And when we think about our connections, and that's where our humanity is based in. And so we're one giant crew on Starship Earth. And so the more we can think of ourselves as one crew that needs to collectively get along and to be successful, I think that is what space embodies, just like Livingston was saying. In the more we put emphasis on that, I think that message gets heard. And I loved what you were saying about generational, because my father worked on the Apollo missions. I was born on Guam because he was at the tracking station there. And so having that generational effect now, so that we're not only inspiring, learning from the past, but we're inspiring the future, and it's all connected.
I like that Crew Earth. I think we're going to get a patch that says, Crew Earth or Earth Crew.
Yeah, I love that. Exactly.
And studying all these things in space really help put Earth in context in the solar system and in the universe. And I think if we can help people understand that, get this bigger picture of the fact that we need to be in this together to be able to survive, and then communicate that well. I think that's the thing that tends to be missing a lot when we're doing this stuff, is communicating the why and how this matters to people in their day-to-day life. And so if we can do that effectively, I think it helps people feel like it's something that matters to them, something that they can be a part of, and understand why this is important for our future.
And Livingston, do you think, obviously I should mention as well, you are a US, you were a US Air Force astronaut in the Manned Spaceflight Engineer program. Do you think space has the potential to unite us, and that while we are divided on Earth by so many things, actually, the more we go into space and the more we look back, we'll realize that we are all crewmates on Spaceship Earth, and space has to be about all of us. And if it isn't about all of us, then we won't succeed in moving forward, outward bound beyond Earth.
I absolutely do. When youngsters look up at the sky, it doesn't matter what country they're in, they still have the same sense of wonder. What's up there? Could I be up there one day? When they see pictures of astronauts flying, especially when they see astronauts that look like them. The more diverse the crew, both in gender and race, the more people can see themselves in those roles, and they say, this is a place for me. This can be my future. I think it has a huge effect in drawing us together and linking us in positive ways. We tend to jump over things that are perceived as barriers, or we societally make barriers, when we have a connection that pokes through those. And engineering, science, exploration, those all burst barriers because they require collective thought, collective interaction. And so I think it's absolutely critical that we continue this work, that we highlight this work, so that we can bring the world closer together, one individual at a time, possibly, but collectively start knitting ourselves together. So we don't view ourselves as separate. We view ourselves as many parts of a single body, if you will.
And Sian, I see you nodding along there if you want to pick up after that as well.
Yeah, and I feel also the arts and what that brings to it. People who inspire us with their futuristic views of exoplanets, and who can bring to life the science that is happening, and the engineering and all those things, and the poets and the songs and all those things that we can help unite us in ways that just make us feel connected to this bigger thing, the cosmos, and why that is important. And so I think that science communication and what we're doing now and expressing our love and our awe for the human ingenuity and the things that we can do when we come together to do amazing things like launching a rocket with a rover and a helicopter to Mars. I mean, it's just fantastic.
Isn't it? I think Bill Nye really hits the nail on the head when he says we are living in the best time. And for all that's gone wrong in the world, we've got so much to look forward to. I love your smile. It's like the widest smile. I love all the enthusiasm coming from all of you. You can just see the excitement. Would you walk on Mars, Sian, if you had the chance?
Oh, yes, I would, but I'm absolutely a moon girl. Send me to the moon or, the overview effect. I'll take any of it, just sign me up.
And obviously, Tanya, I know.
Just give me to orbit. I'd be happy going to orbit.
And obviously, Tanya, I know Mars is your jam. Livingston, are you optimistic for our future?
I am. I think what happens is we have societal ups and downs. We have pendulum swings. And by the way, we can't ignore local, national, and global politics, because the body politic, if you will, is the one that helps fund these missions. We're seeing a shift away from national missions to international missions, but we're also seeing a shift toward commercial. And I think George is probably kind of leading that, giving existence proof that yes, you can do things on a commercial basis. So I think that's important. And I think as we see more commercial activities rise, what that does is, especially if there's a business basis for it, if it looks like I can make money on taking people to orbit, or I can make money on taking people to the moon, or I can make a business out of that. I not only make money, but my business employs people. It employs high skilled people, engineers, scientists, those who have the vision and want to explore. We, the engineers, will help enable that exploration, and it creates a stronger, better society for us generally. And so it does give me hope. It does make me optimistic. Every time we hire a young person or an intern, and I'm just amazed at what tools they know, how enthusiastic they are. I'm going like, I was not this smart when I was your age. So I see that, and I get very optimistic about the future, because these young folks are just spectacular. And I think we just have to make sure that we give them a pathway to go down, and they're going to go way past us.
I think that's a fantastic point to end on. I would love to talk to all three of you all day. And I think you're right. Maybe we're getting smarter as life is getting better as well. And it's just incredible to see all the enthusiasm from young people. Tanya, Sian, and Livingston, thank you so much for your time today. Now, to bring on our final guest, but in no means least, we have Alyssa Carson, who is an aspiring Martian walker. And then we also have retired 4 times NASA astronaut Michael Lopez-Alegria. Obviously, you were both watching the launch. We both got your reactions there. Mike, I just wanted to pick up on the point that Dr. Livingston was saying a second ago. I regave Livingston a doctorate the second time.
I'm going to have to work on that PhD. I really am.
I've given it to you. It's all good. I think you've earned it. Mike, I just wanted to pick up on the point of how, there is optimism and there is hope to come from the young generation. And as someone who's been an astronaut and been to space, how do you feel looking at the next generation of space explorers and the potential that they can have to continue moving us outward bound into space?
Thanks, Sarah. First of all, let me congratulate Rachel and the Space for Humanity team for putting this amazing group of people together. And it's really an honor to be one of them. And I have to say that when I was listening to Bill Nye, I was reminded of that scene in When Harry Met Sally, when the woman says, "I'll have what he's having." Amazing. So look, I kind of agree with Livingston in that, I look at these NASA astronauts that are being hired today, and I don't think I could compete with them. I mean, the people are just more talented, more accomplished. It gets tougher and tougher. And I think that bodes really well for human space exploration in the future. And, I know Alyssa has dreams of joining the astronaut corps one day, and she'll be one of them. And it's true what you said before. Somebody on the planet today will probably be the first person to walk on Mars. And that's an amazing thing to look forward to.
And I want to bring in Alyssa there, because actually what I want to do for the next, at least the next 5 minutes, is give Alyssa my role so that she can represent all of the inspiring young people who want your job, and who want to do what you have done in terms of becoming an astronaut. Like, you're one of the privileged few. Fewer than 600 people have actually been to space. So Alyssa, I want to give you the floor for another 5 minutes, so if you can just throw your questions away.
Yeah, no, I mean, totally. It has been really awesome to kind of take an aspiration, kind of huge, like wanting to become an astronaut, and actually pursuing that and trying to go after that and trying to get involved in as much as early as possible. And of course, being able to be around astronauts who have been to space before and kind of have that inspiration, and to hear that, because, I think that there's always something to learn in that. It's actually so funny. So I actually was making a TikTok a while ago, and this is for you, Michael. I actually did so much research on you. I was doing, all sorts of goofy social media things, but I was doing so many research on all your different EVAs and all the stuff that you were doing to put in the video and talking about how long the amount of time you had been out in space. So it's so funny to have you here and now be talking with you as I just researched all the stuff about you. So it's so funny. But no, it's just been really great to kind of have all these other astronauts as inspirations when you're going after something as crazy as wanting to be an astronaut. But yeah, it's been totally awesome.
And so I think we've got your biggest super fan there, Michael.
Yeah.
What advice do you think you could give Alyssa and everyone watching, because we've got hundreds of you watching still, who wants to be an astronaut, who wants to continue the dream exploring space?
Well, you called it a dream, and I think that's the key message, is you just have to keep following it, and don't try to fit into the profile of what you think NASA's looking for. Pursue whatever you're passionate about. Do what you like, you'll do it well, and you have the best chance of being selected. And now with today's evolution in commercial space, you probably won't have to be a NASA astronaut for very long to be able to fly in space, meaning that pretty soon, I think there'll be more non-NASA astronauts than NASA astronauts that fly in space. So it's a simple message. I used to say to people when I was in my NASA career, you have to study a field in science, technology, engineering, or mathematics. And while those are still important, now you just have to study something that you really, really are passionate about. Do the best you can. Keep your mind open and apply yourself. And that's the best way to do something like this, is just to succeed.
That's incredible advice. Alyssa, what other questions do you have as an aspiring astronaut? This is the chance, I guess, to represent all young people, or to find out what else you can do to make that dream become a reality.
Yeah, I mean, I think, from my experience and everything that I've done, the biggest thing that kids can really do to get involved, I've been huge in trying to, show kids or teach kids that you are able to actually go after your dreams at an early age. You don't necessarily have to wait until you're in college to start figuring out what you want to pursue. If you do get interested in something early on, you can kind of go after those dreams from that young age. And kind of like what Michael was saying, it's all about figuring out what you're interested in. There's no checklist about this, and you become an astronaut. Sadly, you can't go to college and major in becoming an astronaut yet. That's not something that we've established. But it's all about figuring out what you're interested to begin with. And, you can actually make steps towards that from so early on. An easy example, let's say you're interested in robotics and eventually want to do space robotics, even doing something simple as going to robotics competitions or building your own robot when you're in high school or anything like that. All those little things can actually build up along the way to help you later on in a career, whether that is applying to college or applying to an internship or anything like that, to have behind you. But definitely the hugest thing is just being able to talk about your dreams and talk about your goals, because you never know where the opportunities are going to come from. You could be at that robotics competition and tell someone that you're interested in doing space robotics, and they happen to know someone who knows someone, and who knows, you could get an amazing connection from that. So really don't be afraid to kind of put aside your dreams, be very vocal about them so people know what you're interested in doing to help push you along towards your dreams.
And obviously, not only do you have this aspiration of becoming an astronaut, but you're also inspiring many other young people about following their dreams and following careers in STEM. What made you not only have this dream, but decide to act as almost like a pioneer, inspiring young people about why space exploration matters and how space is for them?
Yeah, totally. I got interested in space just at a young age. It just kind of happened, and I just started asking questions. And the more I learned about space, the more interested I was. And when I was young, going to space camp was an amazing opportunity for me to learn more about space, figure out what an astronaut actually is rather than what I was imagining it to be. And so that was really just a really great start into going to space camp and trying to learn all those experiences. And really, I never had planned on speaking about anything or trying to necessarily speak to other kids or anything, because I thought what I was doing was basically all the work that I was putting into it was, I guess, the same amount of work that most kids were putting into their own dreams. But really, especially when the space shuttle program ended, there was definitely that huge gap of people thinking that there weren't astronauts anymore, that space was closed, that everything was shutting down. I even had family members like, oh, what is Alyssa going to do now that there aren't astronauts anymore? And so at that point in time, it really just got me talking more about the future of space, just because I was like, no, there's still astronauts going into space, it's not completely closed. And so it just became more of me talking and trying to teach other people about what was going on in the space industry. And so since that was the start of that, I kind of continued on by speaking to kids, speaking to adults, I guess, at that point on what was going on in space. So that was really the start of it all.
And obviously you mentioned space camp. I went to space camp when I was a teenager. I think so many people on here have been to space camp, or at least like to know. I know there's a Save Space Camp campaign at the moment, and I can see quite a few of you messaging about that. So you can also check that out. The link is on the comments. And Michael, I just wanted to bring you back in, and we talk about space camp, and we talk about the real value in having people inspired at a young age and told that they can do anything that is possible. How important do you think it is to continue inspiring the next generation and continue showing people that it's for everyone? It's not just for one type of society that is involved, or one type of humanity that is involved in space?
Yeah, I think it's very important. And let me, point out what might be obvious, but being an astronaut is not the only way to participate in space flight or human space flight even. I mean, there are all kinds of engineers, technicians, designers, artists, public affairs, communicators. It's a broad spectrum of types of employment that you could look for. But I think it's really just about following your dream. And it's true that something like an astronaut, which is sort of an iconic profile and a pretty visible image of somebody walking in space or sitting on a rocket or something like that, that sort of gets juices going. It's like, the Wheaties box with athletes on the front of them, or, movie stars and things like that. But the real work, as I think Alyssa was referring to, it's not everything that you see. There's a lot of grunt work and training and studying. And so it's not for everybody, but there's almost something for everybody in space. And if space isn't your thing, that's okay too. I can't emphasize enough how important it is to just follow your dream, whatever it may be.
I think that's probably the best advice anyone can be given in life, to follow your dreams. So thank you so much for both of you for your time and for being involved in this incredible event that we've had today. And thank you all of you who are still watching. It's incredible that hundreds of you are still on this. Now, I just wanted to head back to MaryLiz Bender from The Cosmic Perspective, who we spoke to at the start of the show. And she was one of the few people who was actually pretty much just a matter of miles from the launch. So MaryLiz, I was just wondering, we saw your excitement before the Atlas V took off. How are you feeling right now? How was that experience?
Sarah, it is so awesome to see you guys on the other side of this thing. It's such a frenzy. I don't know if anybody has any idea how crazy it is to do this kind of work, but they like, once that launch takes off, you have to wrap up and get out of there in 15 minutes. So, I mean, I'm super sweaty, but I am like full of excitement and just admiration for all the people that make this happen. It's really, I mean, I've been awake since 4 a.m. I got a couple hours of sleep, but I am so full of adrenaline from the excitement of today. And I'm, you know, Ryan and I at Cosmic Perspective, we always say this: the rocket launch is like a ritual for us. It is a moment of pause where we get to stop and consider what's truly taking place. And I've got goosebumps now, just like I do at the launch. You know, I was in tears, and here I am trying to manage a telescope and track this thing. So it's a lot of emotions at once. And now here I am, I'm back at home. I am just a few miles away from the Blue Origin New Glenn pad, from Jetty Park, where all the rocket boosters wade back into port. And I'm just feeling really, I don't know, I can hardly believe that I live in this time and this place specifically, right here, what I call the portal to the universe. It's just a very emotional place to be right now.
I feel like you stole my thoughts, because that's a gateway to the solar system. Yes. Just very quickly, what advice would you give for anyone who is considering maybe one day going to a launch? Should they do it?
Oh my God. Oh, sorry, I just got like way more chills. This is like my passion. So listen, I got my whole inspiration to do what I'm doing because of what many people talked about today. Frank White wrote about the overview effect. I wanted to gift that to people. And then when I actually experienced a rocket launch for myself, I realized that the same thing that's true for astronauts is true for any of your experiences in life. That is, we intellectually know that we live on a planet that's fragile and beautiful and we're floating in space, but you don't truly understand that until you experience it. So that's the same thing for a launch. If you haven't seen a launch in person, total game changer. It is an experience that makes you fully understand what humans are capable of. And it is the most inspiring, full body, visceral feeling that I couldn't possibly explain. You know, we've got a VR rocket launch experience with a haptic suit because we're trying harder to just make it possible for people to feel it and feel the emotion, but it'll never be the same as being here in person. So my advice, there were a lot of great resources for great launch viewing guides. Supercluster has a great one. Ben Cooper, he is the SpaceX and I think NASA photographer. He, or ULA photographer, he has a great launch viewing guide, but there are many great sources. But my main advice, the same advice that Bill Nye gave me: leave the professional recording to all the professional people that have done it 1,000 times, and just bask in the wonder of the experience. Try to just be present for it.
I think that's incredible advice, and thank you so much for your time. Now, I just wanted to bring all of our incredible panelists in one last time, because we are unfortunately at the end of our show, but if we can just bring everyone back in to say a big farewell. And while everyone is coming back, I just wanted to thank our incredible partners, the Planetary Society and Helios Capital, and our very special partner, the ISS and above. Liam is the technical guy behind all of this. So thank you so much to everyone behind the scenes, and everyone can say some final thoughts and a goodbye to all of our audience.
Thank you so much, everyone. Really a pleasure, honored to be here. And thank you to both the Planetary Society and Space for Humanity, all of the guest speakers and panelists today. Some great insight there. Follow your dream and keep doing it.
Yeah, thank you, everyone. And thank you so much, Sarah, for hosting. It was incredible.
Yeah, awesome job, Sarah.
Thank you.
And thank you to ISS Above for this amazing live stream of...
Yeah, we should probably give Liam a round of applause, I think, for all his work behind the scenes.
Yeah.
Thank you, Liam.
Thank you, Liam.
Because what you see, I guess, it's kind of like space where astronauts are the tip of the iceberg, and then you have all these people behind the scenes. You may see a few of us on here, but there's a huge team behind Space for Humanity and all our partners as well, and ISS Above and Beyond and Liam, who have worked so hard to really put this together. So thank you so much for everyone, and thank you most of all to all of you for joining us on this incredible adventure and watching along and sharing this historic day with us as another rover goes to Mars, one which could potentially grab that next piece of evidence, that next piece of the jigsaw puzzle in answering these fundamental questions, such as, are we alone in the universe? Has there once been life on Mars? Are we, as Bill says, potentially all Martian? So it's a hugely exciting day. MaryLiz, I can see a huge smile on your face. Obviously, we are so grateful that you gave us some time to talk about your experience watching the launch. So grateful to all of our panelists, and most of all, grateful to all of you for watching along. Thank you very much.
Thank you. Let's change the world.
Bye.
Thank you, everyone.